Arambikilama guys, my name is Tejaswini Uma Sudhir and you are watching the channel Study with Sudhir. First, I want all of you to put your attendance, subscribe to the channel, hit the bell icon, hit the like button and let's get started. We are going to be doing the chapter Coordinate Geometry. This is something a lot of you have been asking me for in my Instagram DMs, YouTube comments, and here we are with this particular chapter. We are doing this bullet short revision which is called Sabse Tez Maths with Tej. Okay, let's get started. Okay, what do you all know about what is coordinate axis? Coordinate axis, we will draw it like this and then we will explain it to all of you. So you have an x-axis and you have a y-axis. This much of basics all of you must be knowing. This is a plane, okay, with two axes in it. So ideally you have an x-axis, you have a y-axis in a 2D plane, and when you have a 3D plane, you also have a z-axis. Right now you just need to know there is an x and there is a y. Always remember that the x-axis is the horizontal line and the y-axis is the vertical line. Okay, now we will try to put markings for the x-axis and the y-axis. Very often from this particular chapter, you will be given the graph paper and actually asked to first solve questions in your answer script and actually show them on your graph paper. But before that, since we are not having an actual graph paper with us, we will do that with my smart board. You will practice it with your notebook, drawing it in your notebook, and then you will be able to do it in the exam. One thing you must keep in mind while you are doing it in the exam is that there should be scale. That is, one box is equal to 1 unit according to you, or one box is equal to 2 units according to you. That should always be mentioned both for x as well as for y. Okay, please remember to mention that. Okay, so we have various points on this plane. For example, if you are taking this notebook here, this is the x-axis and this is your y-axis. There could be a point here, there could be a point here. What is the address of this particular point? What would you call this point as? With what will you relate this point to? That is what is the address of a point, and that we are calling the coordinate points. Okay, so for example, if I have a point here, what will I call this point? Suppose I am calling this point M. What is this point? We will always start with x and then we will go to y. So we have from the x-axis, if we are drawing a line, it is at 1. So it is 1, comma. Then if we are checking with respect to the y-axis, it is 3. So the point is called, point M is called 1, comma 3. Let us check for another point. For example, my point here is this one and I'm calling it N. What will be the coordinate? Always first check the x coordinate and then check the y coordinate. Okay. So the x coordinate I am drawing, since this is the x axis completely, you have x here and this is the y axis and this is the x axis. From the x axis, if I am drawing a line, I can see it is hitting at -4. So it is -4, comma. From the y-axis, if I am trying to draw a line, it is at -4. So it is -4, comma 4. Okay. Next, I am having a point here and I'm calling it T. T for Teju. Okay. Now, this point T, first we will check with the x-axis. You are seeing it's at -3, so it is -3, comma. From the y-axis, it is at 2. So -3, comma 2 is the coordinate. That is, it is the address. Address don't write in the exam, right? Coordinate. Coordinate is -3, comma 2. Okay. Next, I am taking a point here. I am naming it S. S for Sudhir. Sorry, having a bit of a cough. So, we are trying to find the x coordinate first. You draw a line here. You don't need to draw it if you're able to see it right here. It is 2. So, it is 2, comma. You are drawing it from the y-axis, it is minus 3, so it is 2 comma minus 3. So this is how you are able to find coordinates, so various points on a coordinate plane, on a coordinate axis. And this point out here, that is origin, which is nothing but 0 comma 0, right? Because it's 0 here, 0 to 5, 6, 0 to minus 5, 0 to 5, 0 to minus 5, so it is 0. There is no such thing that you can do only up to number of values. According to your question, you can extend this on this side, you can extend it on this side, up, down, you can do it anywhere you want, okay? According to what are the coordinates that are given to you in your question. Okay, do you understand? Okay, now I do not think I need to explain this to you, that you will always signify this with brackets, right? X coordinate, so it is always in the format x coordinate comma y, x coordinate comma y coordinate. Okay, okay. Now let us go to the next question. Very often you will have to actually draw this on your graph paper, for which same thing, you will draw one line here, you will draw one line here, you will write the scale. That is, you will have one box there, right? One box is equal to 1 meter, 1 centimeter, 1 centimeter is equal to 1 unit, or does it equal to 2 units? For example, if you are suppose this box is here and you are between each box you're putting one number, then it is 1 centimeter is equal to 1 unit. For example, you are saying, okay, nay, this is 1, then accordingly you must change the scale. Okay, I'm sure you've done this in your school as well. Please go back and check what you've done in your graph paper so that you have a better understanding. Okay, now let us go to the next part. Okay, so what you're going to be doing in this particular chapter is predominantly reflection. What does reflection mean? I'm looking at myself in the mirror, I see a reflection. Similarly, when all these addresses, all these points are looking at itself in different mirrors that we are creating, where is it seeing itself in the reflection? That is what we are going to be doing. Okay, let me explain it to you more clearly. So basically what happens in reflection, that it is a transformation. Okay, that is a flip of a shape over a line of reflection. So you have various lines of reflection. Basically, there are various places in which you're actually keeping the so-called mirror. You could keep it in the x-axis, you could keep it along the y-axis, you could keep it along some other line, you could keep it anywhere. And how that particular point is reflecting on the other side, flipping, transforming, that is what we are going to be doing only in this chapter. You could get this as a 1 mark question wherein you are directly just given as a theoretical way, or in section B, what you could possibly get is a entire set, as in probably 4 to 6 marks depending on what are the number of sub bits, wherein they give you a few points. They say find the reflection of that, find the reflection of that. They'll give you a lot of story around it, and then they may say what is the shape that is formed and show it all on the graph. That is what they can give as part of your exam. Okay, so after this particular chapter, I want you to actually practice as well on the graph paper, and I am very sure that any question comes from this particular chapter, you will be able to handle it very, very well. Okay, I hope that happens. Let's go with the question, with the concept. Okay, so what happens if the reflection is in the x-axis? What does this mean? I have an x-axis, I have a y-axis, correct? Correct. I have let's just put some points here, some numbers here, and okay, I hope all of you are actually taking out your notebooks and writing along with me and not watching this like a movie. Okay, so for example, I have a point which is kept here, and I am naming this point as P, and I am asking you, when this particular point P is reflected along the x-axis, what happens to the point? The new point is always called, when a reflection happens, the new point is called P dash. If P is the point, P dash is the reflected point. Okay, so what happens? Let us consider there is a mirror here. Okay, then whatever the point is, it will just come this side. Okay, it will come from this side, it will go this side, but the distance between the mirror and the point will be equidistant to the reflected point and the mirror. What does this mean? What does this mean? Along 2, you will have it exactly here, because between the x-axis and the point, there is a distance of 1 unit, correct? So there will be a distance of 1 unit between the reflected point P dash and the uh, mirror. Okay, so if this particular point was what, 2 comma 1, so the reflected point P dash is what, 2 comma minus 1. So what I want you to remember is, whenever a point is reflected on the x-axis, the y-coordinate becomes the opposite sign. Okay, what did I just say? Whenever you have a point x comma y and it is reflected on the x-axis, the y-coordinate of the sign of the y-coordinate gets reversed. What means x comma y irunda, if it is x comma y, when you put it on the x-axis, when you reflect it on the x-axis, you will get x comma minus y. That is precisely what I've written here. Suppose you have x comma minus y and you're reflecting it, you will get x comma y. Did you understand this? So basically, whatever is the sign of the y coordinate, it gets reversed when you are reflecting along the x-axis. It is the exact opposite. X-axis reflection, y coordinate gets changed. I hope you have inserted that in your brain. Okay, okay, let's continue. Should I give you another example with this? So for example, x comma minus y, let's take a point. So x comma minus y, so I'm taking a point here for example and I'm calling it q. So the point is 2 comma minus 3. When it gets reflected along the x-axis, what is the distance here? 3. So this side also the distance will be 3 and the point will be q dash 2 comma 3. 3 minus 3 to 3. That is what happens in reflection along the x-axis. Okay, now let us go to reflection along the y-axis. So what happens when you're reflecting a point along the y-axis? Let me again draw the coordinate plane. Haath dukta hai yaar. When you keep writing this, your hand starts hurting. Okay, so in fact, I saw a few sarcastic remarks saying that will this series get completed by 2027? See, I'm actually in between some very important exams, so I'm actually taking. I'm trying to manage my time between these videos, preparing them, understanding what are the important concepts which may come for your exam, and also studying for these very important interviews. So, it kind of takes time balancing. So that's why, and also one reason was that. Uh, you had your second language exam in between, at least some of you had, right? So I wanted to not burden you with a lot of videos in the beginning, so that people who are having their second language don't feel like they're missing out on something. One has to be equal to everyone, right? And that is why I was putting one video before your language, and after that we'll obviously increase the frequency to help you all. So it's kind of sad when you hear such comments. Okay, anyways, so let us take a particular point as an example. So if you're taking the point here and we're calling it P, what is the coordinate of this point? Minus 2, because we're first going to see the x-axis. So it's minus 2, comma, minus 2, right? And we are reflecting it along the y-axis. That means the mirror is here. What is the distance between this point and the y-axis, point and the mirror? It is 2 units. So this side also we have to take a distance of 2 units and put the point P dash, which will be 2 comma minus 2. What is happening here? You had x-axis, x coordinate is reversing its sign. So as you must have realized, whenever you have a point which is reflected along the y-axis, the x-coordinate will change its sign. If it is x comma y, it will become minus x comma y. If it is minus x comma y, it will become x comma y. Okay, so you have to understand, if it is reflecting along the x-axis, the y-coordinate will change its sign. If it is reflecting along the y-axis, the x-coordinate will change its sign. Okay, chalo. Next, we will go to the next part. Reflection in the line y is equal to x. What happens when you're reflecting along the line y is equal to x? So you have the x, you have the y, right? What does this mean, y is equal to x? What happens when y is equal to x? Suppose this is 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3, minus 4, 1, 2, 3. Okay, so if you have a line which is x is equal to y, it will look like this. Why will it be looking like this? Because it has to follow that if x is equal to y, let us substitute the value of x as 1. So if 1 should be equal to y, that means both of them should be going together. That means if it is if x is 1, y has to be 1. If x is 2, y has to be 2. If x is 0, y has to be 0. If x is minus 1, y has to be minus 1. And that is why the line will move like this, and it is called x is equal to y. That is the line. So if you have a point, for example, you have a point 3 comma 1, okay, and when this particular point is reflecting along the line x is equal to y, p is equal to 3 comma 1, then it becomes p dash will become y comma x, as in it will become y, which is 1 comma 3. P dash will be 1 comma 3. Can you see this? Whatever is the distance, the perpendicular distance from here to here is the same perpendicular distance from here to here. Of course, because it's not according to scale, I have not been able to show you exactly. It does not look very similar, but that is how it is when you're actually drawing it in a graph. Okay, so basically what you need to remember, if it is x comma y, it becomes y comma x. Okay, you just need to, it just gets ulta, it gets interchanged. Okay, that's what you need to remember if it is along the line y is equal to x. Now, what happens if it is reflection in the origin? If it is reflection in the origin, x comma y becomes minus x comma minus y. If it is reflection in the origin, it becomes minus x. Basically, it completely changes the coordinate. Yeah, so it becomes, if you have something here, it becomes here. If you have something here, it becomes here. These are the 4 quadrants, right? You do not need to know these details, but these are the 4 quadrants of coordinate geometry, right? So it completely changes sign. So you have quadrant 1, quadrant 2, quadrant 3, quadrant 4. So it completely changes sign. Here you have x comma y. Here you have minus x comma minus y. Here you have minus x comma y. Here you have x comma minus y. Right? So this is what happens along the origin. Okay. What is an invariant point? So point which remains unchanged after a reflection is known as an invariant point. Unchanged after reflection. Very often when we do a reflection as well, you have a point, there is no change in the point, there is no reflection to that point when you're doing either along the x-axis or along the y-axis or along a particular line. If there is absolutely no change, it is known as an invariant point. Okay, let's go to the next slide. What I want you to do is actually solve this particular question, and then we will discuss how it has to be done. Okay, please start solving that question. Okay. Are you guys ready? I hope you pause it and solve it, because I won't be giving like 5 minutes to solve it, but I hope you have paused. Okay. Let us start. Okay. So you have a point A comma B. Point A comma B is reflected in the y-axis. Reflected in the y-axis. To P dash, which is called minus 3 comma 1. Right? Write down the values of A and B. Okay, listen. If a point is reflected along the y-axis, then the x-coordinate will change its sign. You guys know this. You guys are smart kids. So, if you have minus 3 comma 1, that means only the x-coordinate has changed its sign. So, therefore, this will be 3 comma 1. So, P will be equal to P's address, P's coordinate will be 3 comma 1. Yes, am I right? Yes. Okay, so this will be A is equal to 3, B is equal to 1. Okay, let us go to the next part. We have the first part already ready. Okay, P double dash is the image of P when reflected in the x-axis. So P, when it is reflected in the x-axis, it becomes P double dash. P is how much? 3 comma 1. When a point is reflected in the x-axis, then we will change the sign of the y-coordinate, right? So it will become 3 comma minus 1. So P double dash is equal to 3 comma minus 1. Are we clear, guys? Are we clear? Are we clear? Brothers and sisters, brothers and sisters. Okay, so next question is P double dash is the image of P when reflected in x is equal to 5. Okay, shall we draw a coordinate axis and check? Okay, so whenever in doubt, just draw the axis and you will find the answers. Whenever in doubt, draw the coordinate axis. Draw the coordinate axis. Okay. Okay. Sure. So, I hope you're doing it along with me. Okay. So, let's first draw P. P is 3 comma 1. That is 3 comma 1, which is P is here. Okay. Then 3 comma minus 1 is P double dash. So 3 comma minus 1, which is along the x-axis, right? Yeah. So P comma minus 1 is P double dash. Okay. Then P triple dash is the image of P when reflected in x is equal to 5. Now, what is x is equal to 5? X is equal to 5 basically means go to x-axis. Go to x-axis. I just had to move it a little because I had to extend that. Go to x-axis and see where is 5 and then draw a line along 5, because the entire line will be x is equal to 5. So we are drawing an entire line like this. This line is called x is equal to 5. Please make a note. And then this is 5, this is 6, this is 7. Okay, I'm just doing it so that it fits into the board. So we know that we have to reflect this P, we have to reflect P along x is equal to 5. What is the distance from the mirror x is equal to 5 to P? 2, right? So we move this just to this side, that is here. Am I right? Yes. So P triple dash will be nothing but 7 comma 1. Okay, So the coordinates of P triple dash will be 7, 1. Wherever your mirror is, find the distance, see what is the distance between your point and that mirror, the perpendicular distance, perpendicular as in 90-degree distance. That means straight distance. And the same distance, equal distance, you have to do the reflection. Okay? That's what you will even learn eventually when you even do your mirrors physics chapter on reflection. Okay, so this is how you are able to find. Also, x is equal to 5 would mean go to where 5 is on the x-axis and then draw a straight line, because entirely wherever in this line you go, the x coordinate will always be 5, and that is why that line is called x is equal to 5. I hope this is clear. We have found out all the three parts of this particular question. Let us go to the next one. Chalo. I want you guys to now, since you have got a hang of how this is done, I want you to solve it on your own and then we will do it together. Okay? Chalo. Okay. I hope you have paused and you have some idea on how this is to be done. Okay. So Px comma y is reflected. Px comma 5 is reflected in the y-axis to p dash minus 4 comma 2. Okay, so Px comma y is reflected along the y-axis, okay, to p dash minus 4 comma 2. So if it is reflected along the y-axis, the x-coordinate will change. So this has to be, p has to be 4 comma 2. Correct? Correct. So the coordinates of p is 4 comma 2. Okay, let us go to the next part of the question. Okay, chalo. Just a second, my mom is calling. Let me just answer. Amma recording la iruken. Yeah, let us start. Okay, so P double dash is the image of P dash when reflected in the line x is equal to 1. Let us first draw the line, draw the axis, and then we can start. Okay, so you have y-axis here, x-axis here. So you have 1, 2, please write it down along with me. So however, whatever you would be doing, you should always answer when your mom calls. Okay, that's why I answered. 1, 2, 3, 4. Okay, so let's just plot P 4 comma 2. So your 4 comma 2, this is your P. Okay, then P double dash is the image of P dash. So P dash is minus 4 comma 2. So minus 4 comma 2 was P dash. Right? P double dash is the image of P when reflecting in the line x is equal to 1. So x is equal to 1 is this line, right? Why is this the line? Because anywhere on this line, the coordinate of x will always be 1. So this is the line x is equal to 1. Let us reflect this point P dash on x is equal to 1. What is the distance? 4, 5. 5 is the distance from minus 4 comma 2. So when you move it this side, you have to have a distance of 5. Let us just extend it a little. Yeah. So 4, 5. So this side 1, 2, 3, 4, 5 and 2. So it will be P double dash will be nothing but 6 comma 2. Is that clear, guys? 6 comma 2 will be P double dash. Okay. You have to take the same distance from the point to the mirror and the other side as well. Okay. Next, they are asking you P triple dash is the image of P double dash when reflected in the line y is equal to 3. Y is equal to 3, find the y-axis and where 3 is there, draw a line. Yes, because along the entire line, the coordinate of y will be 3. So y is equal to 3. Right? This is the line y is equal to 3. Coordinates of P triple dash. P triple dash, P double dash is here. You are at 2 and there's a distance of 1. So this side, let us just erase where we had, so this was P, this was P double dash, and from 2, this is the distance of 1. So this side distance of 1 will be P triple dash. And P triple dash, so basically P triple dash, the value will be 6, comma 4. Is that correct, my friends? Yes, because y is equal to 3 is the line. You have a distance of 1 unit between this point and the line. So the other side, the opposite side, 1 unit you need to take, and therefore the coordinate will be 6, comma 4. And therefore the value is 6, comma 4. Okay? Chalo. Next, let's go to the next question. Okay, let me exit, quit, and then let's go to the next question. Okay. Please solve this particular question. This can be a potential 4 marker in your exam. Okay. So I hope that you guys will be able to do this after all the practice we have done so far. It's a pretty simple question. Very direct and easy to score. Okay. I hope you've paused the video and then we can start. Shall we begin? Yes. Arambikilama, guys. I hope everyone's previous exams have gone well. If not, this is your opportunity to shine. Okay. Let us draw the axis. While you do too, I will also draw the axis. तेरी उंगलियों से जाल छे कोई टोह टोह ना लागे किस तरह गिर ये सोचे Okay, so what I did so far was that I was trying to plot the 4 points that were given to me. So 1 comma 2 is 1 comma 2, 3 comma 2 is 3 comma 2, 3 comma 4 is 3 comma 4, 2 comma 5 is 2 comma 5. Okay. Next, reflect the points A, B, C, D in the x-axis. So when you have to reflect on the x-axis, the y coordinate will change, right? So 1 comma 2 will be 1 comma minus 2. So A dash. B will be 3 comma 2 will be 3 comma minus 2 will be B dash. C is 3 comma 4, so it will be 3 comma minus 4, which is C dash. D is 2 comma 5, so D will be 2 comma minus 5, which is here, D dash. Okay, write down the coordinates. I hope you have written it down. Should I write it here? Okay, so you have 1 comma minus 2, 3 comma minus 2, 3 comma minus 4, 2 comma minus 5. Okay, those are the coordinates, because along the x-axis you're trying to change the y coordinates, right? Because the reflection is along the x-axis. Reflect point D dash in the y-axis to obtain the point D double dash. So along the y-axis, already D dash is 2 comma minus 5. When you're doing along the y-axis, it will become minus 2 comma minus 5. That is, it is here. D double dash is basically minus 2 comma minus 5. We have plotted it here because, is it not exactly plotted? Minus 2 comma minus 5, D double dash. Okay, plot all the points A, B, C, D, A dash, B dash, C dash, D dash, D double dash on a graph. We did that. You can do it on your graph paper. That's what they're asking for. Okay, identify the shape formed by joining the points A, B dash. Let me form A, B dash. You do it with a scale, please. C dash, D dash, D double dash. Okay, so they are asking you what is the shape. So how many vertices does this have? 1, 2, 3, 4, 5. Are all the sides between all the vertices equal? 1, 2, 3, 4, 5. Are they all equal? No. So we can call it an irregular, because they are not equal, irregular pentagon. Isn't it? Can we call it an irregular pentagon? Because we have 5 sides, 1, 2, 3, 4, 5, but they are all not equal. So we are calling it an irregular pentagon. Okay. That's it from my side for this particular chapter, coordinate geometry. What I want you to do, first of all, practice on graph paper. I'm sure you may have been given the graph books in your schools, or you could buy a graph book from your stationery near you. Practice on graph papers. Always remember scale ऊपर की तरफ लिखना है. That means మేల side ला పైన scale రాయాలి. Okay. Second thing you need to remember, always use a pencil and scale as in a proper scale, and plot it neatly basically. Okay, write it on your both in your answer script what you're plotting, and then you go and plot, say that it's plotted on the attached paper, and then you can plot it. Okay, so that's all with respect to coordinate geometry. I hope all the concepts are clear. There are very few concepts that you need to actually remember, and once you know the small tricks on when you are reflecting in a y-axis, the x coordinate changes, or when you're reflecting in the x-axis, the y coordinate changes along the origin x comma y because minus x comma y, or what happens when you're doing along a particular line like x is equal to 3 or y is equal to 2, what happens, you have to measure what is the distance and the same distance on the other side, or in terms of x is equal to y, what happens. All those different cases, if you have learned, you will be able to easily solve questions for coordinate geometry. It is a direct question for you in your board exam. Okay, thank you so much for watching, and I'll see you in the next one.